Welcome back. All right. So now that we know if we can build a triangle, we want to talk about what kind of triangle we're dealing with. Like I previously mentioned, we know scalene, we know isosceles and equilateral. That is based on the side lengths. What we're going to look at now are our angles. How do we classify our triangle via angles? So we know we have right triangle, we have acute and obtuse. How do I figure out if my triangle is one or the other and all I'm given are the side lengths? Let's take a look. So the first one we should be pretty familiar with, the right triangle. We know that if our triangle is a right triangle, we can use the Pythagorean theorem. But we could actually use the Pythagorean theorem to prove my triangle is right. That's simple. So if I had some triangle and all I know is side lengths A, B, and C, and I test it, A squared plus B squared equals C squared. If they're equal, I am guaranteed that this is going to be a right triangle. That's it. So we know if we're given a right triangle, we can use the Pythagorean theorem. But if we're just given the side lengths, let's test it out. Does it satisfy the Pythagorean theorem? Yes, it's a right triangle. Okay? What happens if it doesn't satisfy the Pythagorean theorem? For example, again, say we have some triangle. I don't really want to make you assume what kind of triangle it is based on the drawing, so I don't want you to be like, ooh, it looks like it's acute. I don't know. But side A, B, and C. Little disclaimer, we always want C to be the largest number. That's how we're going to test. Always, okay? So C will always be the largest number. If I test this out, A squared plus B squared, and it is actually bigger than C squared. So now they're not equal. A squared plus B squared is bigger than C squared. That is going to give me an acute triangle. Plain and simple. Okay? What's happening there is my A squared and my B squared, when I go ahead and add those up, if it's bigger than C squared, that's creating a smaller side, smaller angle, right? If they're equal, it's creating a 90 degree. If it's smaller or bigger, like we're saying here, it's creating a smaller angle there. So on the flip side, what happens if it's smaller than? That means it's opening up, creating a bigger angle there. So if A squared plus B squared is smaller than C squared, that is going to give me an obtuse triangle, meaning one of my angles is bigger than 90. If it's acute, all of my angles will be less than 90. That's it. So if we were to give this a test, let's see here. Let's have the side lengths 5, 6, and 7. First of all, is it a triangle? We check. 5 plus 6 is bigger than 7. 6 plus 7 bigger than 5. 5 plus 7 bigger than 6. Check. 7 is the biggest, so I'm going to do 5 squared plus 6 squared, and I'm going to compare that to 7 squared. So that's going to be 25 plus 36, and I'm going to compare that to 49, right? So that's 41, so this is 61 compared to 49. 61 is definitely larger than 49, so we have an acute triangle. That's all it is, okay? Let's go ahead and test this one. Let's try... Okay, let's do 3, 4, and 6. Okay, so 6 is the bigger number. Again, we could test. 3 plus 4 is bigger than 6. 6 plus 4, 3 plus 6. Yeah, we're good. So 3 squared plus 4 squared, and we're going to compare that to 6 squared. So that's 9 plus 16 compared to 36. So 25 compared to 36. 36 is definitely bigger. So we have an obtuse triangle. Okay? Good luck. Go forth. If you got questions, let me know.